Hi, I am Basant Pathak, a medical student and the statistician. Welcome to Handy Research. In previous episodes, we discussed confounding, directed acyclic graph models, adjustment, selection bias, information bias. Today, we clarify something extremely important and commonly misunderstood. When we see differences across groups, are those differences biased or are they real? Today, we answer what is the difference between confounding and effect modification. Understanding this distinction is a turning point in research thinking. So let's begin. Effect modification versus confounding. When the differences matter. Practical Guide to Research, Season 1. So the central question. Suppose we study smoking and lung cancer. The famous example always. Smoking leads to lung cancer. For that, we calculate the crude risk ratio. And now we stratify by sex. Now we find among male risk ratio is equals to 4. If you do not know about risk ratio, it is risk in exposure to risk in non-exposed. Risk is always case by total number, that is the risk. Now among male risk ratio is equals to 4 and among female risk ratio is equals to 2. The association differs. Now we must ask, is sex distorting the association? Is sex distorting the association, or is sex changing the strength of effect? Changing the strength of effect. They are not the same. If sex is a confounder, we adjust it and report one corrected estimate. But if sex is effect modifier, we report two different effect. Okay, we describe it, and that decision changes the interpretation completely. Now let's revise this clearly. What is confounding? I think I have explained this many times, and confounding till in the foundation season it comes in every lecture. So when does confounding occurs? It's the simple when third variable is associated with both exposure and outcome. Okay, third variable exposure in associated with both exposure and outcome, and distort the true association. So the same structure, that is the confounding related to the exposure and confounding related to the outcome. Our famous example again, like age related to the smoking. Yes, the older age more prone to have smoker, and age also related to the lung cancer. Like so, older people smoke more, and older people have higher cancer risks, and that age creates imbalance. Age creates imbalance, then that is the confounding is bias. It must be controlled, yes. After proper adjustment, the distortion disappears. Now, what is effect modification? Okay, next jump into the effect modification. Effect modification occurs when the effect of exposure on outcome truly differs across labels of another variable. Did you get my point? The effect of exposure on outcome truly differs across the labels of another variable. This is not bias, this is heterogeneity. And this is the real biological or contextual variation. Let's take an example like drug leads to the mortality. Drug leads to mortality. Now in younger patients, let's suppose again the risk ratio is equals to 0.5, and in elderly risk ratio is equals to 0.95. This is the imaginary valuable. The drug works strongly in young and barely in elderly. But this is not the distortion. This is reality. Because effect modification tell us for whom does this exposure work best. Here, age is not confounder because there is lot of biological variability that leads to young survive well and elder not survive. That is the barely they survive. That's why it is effect modification and not the confounder. It adds meaning. It add meaning, or it add meaning, not bias. Not bias. That's why I already explained it is heterogeneity. It is a real biological or contextual variation, and it is not bias. Okay, let's go through the fundamental difference. What is confounding and what is effect modification? Confounding, it creates the false association, creates false association, like it distorts the magnitude, है ना? While effect modification reveals true variation in effect, and it is nuisance. Confounding is nuisance, while effect modification is meaningful. It is meaningful. Confounding should be removed. Effect modification should be reported or described. Should be reported or described. It is similar stratum specific estimate. Confounding is similar stratum specific estimate. Stratum doesn't confuse with the stratum. They are the variable like age, sex, that are the stratum. And effect modification, stratum specific estimates differ. Here is one hide the truth, confounding hides the truth, and others reveals complexity. That is the effect modification reveals complexity. Okay, how to distinguish them step by step? Let's go through it. Step 1. First, what we will do, that is the calculate crude association, that is the crude association or crude risk ratio. Second is stratify it by variable, divide it by variable. Now examine the stratum specific estimates. Now let's take in case A. For case A, crude risk ratio is equals to 2, and stratum 1 risk ratio is equals to 3.0 or 3, and stratum 2 risk ratio is equals to 3.1. Again, I tell you that stratum could be anything like age, sex, that leads to the distortion. And stratum estimates are similar to each other but different from crude. That estimate or that interpretation is confounding exist. Remember, it is the confounding exist. It is uh, uh, deviated from the crude risk ratio, but they are quite similar. Stratum division are quite similar, but they are differ from the crude or real. That's why it is the confounding. The crude estimate was distorted, but after adjustment, report risk ratio is equals to 3. So after we adjust that variable, after we adjust that variable, we got our true or crude risk ratio. That's why that is the confounding. But in case B, same risk ratio, crude risk ratio is equals to 3, and stratum 1 risk ratio is equals to 5, and stratum 2 risk ratio is equal to 1.5. Now stratum estimates differ from each other. Remember, there are same stratum 1 risk ratio and stratum 2 risk ratio are quite similar to each other, but here it is differ from each other and differ from the crude risk ratio as well. That's why they are effect modification. In simple example, like while we examine the risk ratio of whole population, then it comes to 3, but in younger patients it is 5, and in older patient it is 1.5. It means that there is a biological plausibility. That's why there is the effect modification, and there is no true effect. There is no single true effect. That's why there is no single true effect. That's why we report both. What's key rule here? If stratum specific estimates differ from each other, that is the effect modification. And if they are similar but differ from crude, then it is the confounding. Did you get my point? Now let's go through the detailed numeric example. Again, let's change the example. Today there's alcohol causes the liver diseases. Alcohol causes the liver disease. Again, stratify by sex. In men, risk exposed is equals to 20%, and risk unexposed is equals to 5%. Then risk ratio is equals to 4. I already tell you that risk ratio is equals to risk exposed by risk unexposed. In human, risk exposed is equals to 8%, and risk unexposed is equals to 4%. Then risk ratio is equals to 2. Now the effect differs. Now ask, what do you ask? Does sex cause alcohol use? First question will be yours, that does sex causes the alcohol use? Might be or probably. According to we see the results, they probably causes the alcohol use differ in sex distribution. And again, does sex cause liver disease? Again, it might be yes. The result shows us like that. So sex could meet confounding criteria. But stratum specific estimates differ as well. Here in male and female as well, they are different. That's why sex is not only confounder but it is effect modifier. Even if variable is associated with both exposure and outcome, that is the definition of confounding. If it changes the magnitude differently across strata, we treat it as a effect modification. Now let's go through the biological meaning. What does effect modification exist, or why? Why? Because humans are not uniform. Humans are not uniform. Some are healthy, some are athletic, and some are bored, lazy guy. So humans are not uniform. That's why they have also genetic polymorphism, different sex hormones. They have different immune system. That's how I'm gonna focus. They have different immune system and they have different age related metabolism as well. So that's the different exist in human metabolism. And so again, the example like the smoking causes the lung cancer are famous. Like we have already taken this example thousand times, I guess. Maybe genetic variant increases the susceptibility. Gene modify effect on smoking. Effect of smoking. This is the effect modification. It helps personalize medicine. Now interaction in regression. Statistically, effect modification is tested through interaction terms. For example, there is a one model where B naught exposure plus B naught is no exposure, B1 first exposure, B2 or could be the modifier, and B3 could be the modifier into a modifier and the exposure both. That leads to the outcome of the study. And B3 represents interaction. It represents always interaction because I have already told this is exposure and modifier. But if B3 doesn't equals to 0, the effect differs across modifier level. I will explain the regression detail in analysis parts. Here, just go through the lines I have told you. But statistically significance is not everything because clinical relevance and the plausibility matter. That what we got from the effect modification. Effect, clinical relevance and plausibility always matter. Now, additive versus multiplicative scale. Let's understanding this deeply. Which scale is important in which factor? Effect modification depends on scale. On multiplicative scale, we use risk ratio, and on additive scale, we use risk difference. Okay, because if in multiplicative scale, effect may appear constant, while on additive scale, effect may differ. Example: young baseline risks. Okay, there is a risk of 1% in young and 10% in elder. Now, drug reduces risk by 50% in both. If the drug reduces risk by 50% in both, then risk ratio is decreases by 0.5. 50% is 0.5, But risk difference, what would get, how much risk difference we got? In elderly, if 0.5 risk ratio decrease, then we got only 50% decrease, we got only 0.5% reduction. And in elderly, what is the 50% of 10%? That is the 5% reduction. So on additive scale, effect modification exists. That's why on additive scale, effect modification exists. Public health decision, that's why rely on absolute difference. Always clarify the scale. We have to clarify the scale always. Okay. Now, directed acyclic graph perspective. We have already explained maybe in second and third lecture. Confounder creates backdoor pathways. Same confounder leads to the exposure, and confounder leads to the outcome. So effect modifier does not create does not create spurious path. It changes the strength of exposure to outcome link. It modifies arrow thickness. That is, remember, it modifies arrow thickness, not the direction. Did you got this line? Arrow thickness means magnitude increases, not the direction. Now, practical analytical strategy. What is the strategy of this lecture? What is the strategy between the confounding and what is the strategy between the uh, What is the strategy between the effect modification? Okay, first identify confounder. Which model do you use to identify confounder? That is a DAG model. Then adjust it, explore effect modification, report the starter specific estimate, and interpret biological meaning. So what you should not do? Never confuse the two. Simple. Never confuse the start confounding and the effect modification, and never adjust way real heterogeneity. Real heterogeneity like between the age we have already explained effect modification. Never adjust away. Now common error. What are the error that the researcher gonna do continuously while doing it? They call effect modification as residual confounding. That's one error. They ignore subgroup difference, and they fishing for interaction without specification. Interaction without pre-specification. Do you know subgroup analysis must be pre-planned? Biological plausibility, biological plausible, and interpreted cautiously. Now, effect modification in meta-analysis. Do you know between study heterogeneity may reflect effect modification? For example, let's suppose drug work better in African while than European. Meta regression can explore the effect modifiers. Again, I will explain this detail in analogic lecture, but ecological bias, ecological bias risks exist. This exist. So that's why we have to interpret it carefully. Now, the final conceptual clarity of this lecture is always ask two questions. Is this variable creating imbalance, or is it revealing biological variation? So if there is imbalance, then we have that is the confounding, and if it is the biological variation, that is the effect modification. Now, last line to remember: confounding is something you control. Confounding is something you control, and effect modification is something you describe. Always remember that. Always. Okay, thank you for watching, and follow Handy Research, Practical Guide to Research. This is your episode 9. This is your episode 9 done of 150 episode series. Thank you.